Hello and welcome to the video on Chapter 21, where we'll be talking more about hypothesis tests and intervals. All right, so there's quite a bit to talk about on the null hypothesis. And in Chapter 21, the very beginning of the chapter, again, talks about all of the things we're supposed to talk about with the hypotheses, especially the null. So here are some statements that I created. First, the null hypothesis have special requirements. To perform a hypothesis test, the null must be a statement about the value of the parameter for a model. Usually we've been using a normal model. But it could be any, to begin with, remember, it could have any shape to start with, but when we sample from that, the sampling means we'll have normal, usually. And thirdly, um, once we have that, again, the null hypothesis must be about that parameter. Once we have that parameter, we then use this value to compute the probability that the observed sample statistic or something like even higher or lower than that might occur. All right, so once we have that, then how do we choose the null hypothesis? Well, again, just like in chapter 20, the appropriate null arises directly from the context of the problem, and it's not dictated by the data, but instead by the situation. One good way to identify both the null and the alternative hypotheses is to think about the why of the situation. To write a null hypothesis, you can't just choose any parameter value you like. The null must relate to the question at hand. It is context dependent. So again, it depends on the wording of the question, and that is, again, what helps us dictate what the null hypothesis equation is. There is a temptation to state your claim as the null hypothesis. So again, be very careful on how that is done. You can't prove a null hypothesis is true. So what we do, it makes more sense to use what you want to show as the alternative. This way, when you reject the null, you're left with what you want to show. So again, how we're thinking about these tests and what those p-values stand for. So a p-value is a conditional probability. It's the probability of the observed statistic given that the null hypothesis is true. The p-value is not the probability that the null hypothesis is true. It's not even the conditional probability that the null hypothesis is true, obviously given the data. So we have to be very careful to interpret the p-value correctly. And again, that was all done in chapter 20. So what happens when we have a high p-value? Well, let's first talk about small. When we see a small p-value, we could continue to believe the null hypothesis and conclude that we just witnessed a rare event, right? We could say that even though our data shows that the null hypothesis is not true, even though our data shows this, we could still say that the null hypothesis is valid. So we have that option. But in this case, what we normally do, we trust the data and use it as evidence to reject the null hypothesis when the p-value is small. So however, when we have a big p-values, that just means that we observed something surprising. We could, again, say that because we have a large p-value, we could still reject it. But again, that would be a difficult thing to do. But we could. And again, we're going to go through the situations that we could do in a few more slides, especially with rejecting and not rejecting the null hypothesis and what happens when that happen when we do that. So again, on the second bullet, it's the results are now in line with our assumption that the null hypothesis models of the world, so we have no reason to reject it. So again, when you have a large p-value, that's the status quo. It just says that what we originally said about the null hypothesis is true. So, or it's valid. So again, when you have a small p-value, normally we would reject the null hypothesis. With a large p-value, we would fail to reject it. The fourth bullet here says a big p-value doesn't prove that the null hypothesis is true. So make sure you understand that. It certainly offers no evidence that it's not true, but it doesn't say that it is true. Be very careful with the wording on your answers. So thus, when we see a large p-value, all we can say is that we don't reject the null hypothesis. Hopefully, again, that makes sense. In alpha levels, or critical values, sometimes we need to make a firm decision about whether or not to reject the null hypothesis. And when the p-value is small, it tells us that our data are rare, given the null hypothesis is true. Well, then again, you have to think about, well, how rare is rare? And that again goes back to the situation that's at hand. So we can then define rare event arbitrarily by setting some type of threshold for our p-value. So if our p-value falls below that point, we'll reject HO, or our null hypothesis. We call such results statistically significant. The threshold is called an alpha level, denoted by, well, the Greek letter alpha. Common alpha levels are 10%, 5%, and 1%. The standard is 5. That's the one, the default. You have the option, almost the obligation, to consider your alpha level carefully and choose an appropriate one for the situation. The alpha level is also called the significance level. When we reject the null hypothesis, we say that the test is significant at that level. And again, you define which level you're using when you reject or fail to reject. So what can you say if the p-value does not fall below alpha? Well, you should say that the data have failed to provide sufficient evidence to reject the null hypothesis. Don't say that you accept the null hypothesis. Again, that was in chapter 20. Please don't say that. That's not in your writing. So recall that in a jury trial, if we do not find the defendant guilty, we say the defendant is not guilty. We don't say that the defendant is innocent. All right, so I'm going to pause here and go back to the end of my video, and we'll be right back.